Hello and welcome. My name is Shannon Kemp, and I'm the Chief Digital Officer of DATAVERSITY. We would like to thank you for joining the latest installment of the monthly DATAVERSITY webinar series, Advanced Analytics with William McKnight. Today, William will be discussing translytical databases, a framework for evaluation and use case analysis. Oh my goodness, I'm tongue-tied today. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we'll be collecting them by the Q&A section. And if you'd like to chat with us or with each other, we certainly encourage you to do so. And just to note, the Zoom chat defaults to send to just the panelists, but you may absolutely change that to network with everyone. To find and open both the Q&A and chat sections, you can find those icons in the bottom middle of your screen for those features. And as always, we will send a follow-up email within 2 business days containing links to the slides, the recording of the session, and any additional information requested throughout the webinar. Now, let me introduce to you our speaker for the series, William McKnight. William has advised many of the world's best-known organizations. His strategies form the information management plan for leading companies in numerous industries. He is a prolific author and popular keynote speaker and trainer. He has performed dozens of benchmarks in leading database, data lake, streaming, and data integration products. William is a leading global influencer in data warehousing and master data management, and he leads McKnight Consulting Group, which has twice placed on the Incorporated 5,000 list. And with that, I will give the floor to William to get today's webinar started. Hello and welcome.
Thank you, Shannon, and welcome everybody. Shannon, I trust my screen share is okay?
Yeah, looks great.
Okay. Sometimes Zoom swaps me on that on the screens there, but okay, great. So again, welcome. This is to me, it's an exciting topic. I don't know if it's my most popular topic, probably not, but it leads into the simplification of our data architecture that we so desire out there in every enterprise. When I do my action plans, it's definitely something that comes up every time is we need to simplify here. We need to look for ways that we can do 2 for 1, 3 for 1, and eliminate some of these data structures that have grown up over time because they're all in the cloud. So it's so easy to provision, but it has been a nightmare for data architecture. So let's see if this might be something that could help, this being the topic of today, translytical databases. So translytical is obviously transactional and analytical, also known as HTAP, HTAP. And HTAP, HTAP was, you'll hear me say it time to time, it was a Gartner term from about 2019, I believe. They have replaced it with a term called augmented transaction database, which also encompasses operational AI. That term hasn't really taken off, so I'm going to stick to HTAP, which is the term most people use. I'm not trying to forge terms here or anything like that, just letting you know where I'm coming from and the terms that I will use today. Now, another subject that's sort of wrapped up in this is multimodal databases. It's an entirely different dimension to a database. That is, whether it can be translytical and whether it can be multimodal. However, because the two get conflated and actually a database that's both is super great because of all of the capabilities that it can do. I will spend a few slides on multimodal as we get towards the end of the presentation. So many modern HTAP systems do benefit from being multimodal, as this allows them to handle the diverse data types and structures, which can be useful for both kinds of workloads. Here we are in the year. As the year moves on, so do we. Translytical database is the topic for today. The second Thursday of every month at this time. Mark it right there in your calendar. Come on back. What I like to say is that on a rolling 12-month basis, these webinars are going to put you at the top 1% of knowledge in the data profession. And all of the historical ones are on YouTube, in case you want to go back and catch up a little bit. There are the subjects: data management, analytics, and AI, focusing on trend strategies and innovations in data architecture, information management, products, RAG, and AI. And this will be, actually next year, will be the 8th year running for this series. And I am very pleased to be here for you and thank you for joining. These are some of the technologies that we work with at my firm. We've had all these in a working form at a client or in a benchmark. We do a lot of that stuff too, and then some. So you can see where we're coming from, a lot of data products in there. So decisions, decisions, decisions. Yes, we have a lot of decisions. I am not sure that I am completely synced here. Let me see. Okay, so I know what I need to do. Sorry about that. Decisions, decisions, decisions. Okay. There's an unprecedented variety of data store choices to meet the needs of the varied workloads. I already mentioned that simplification was a huge issue. And the complexity of our architectures means we don't know where data is. We just create it redundantly because we don't know, which creates more redundancy. Does that sound familiar? It does in many of the enterprises that I've been in. Enterprises have many needs for databases, cache, operational, data warehouse. These are all database types. And historically, they've all been in their own segment. And that's been okay. But now that we're at the point we are in 2025 with the complexity of our information infrastructure, it's not okay so much anymore because we are hitting inflection points in terms of we're never going to get back to an architected position if we just let things continue to go in the direction that they're going. And it could actually be perilous for the company itself to try to carry that burden of debt through the future. Now, while vendor offerings have exploded in recent years, in due time, frameworks will integrate components. I've been saying this for a few years, and it hasn't completely happened yet, but it is one of these things that is coming surely over the course of time. It has happened in that we see major vendors acquiring companies, having complete frameworks for doing all of the things that we need to do with data, all the way from governance to graph to vector and so on. This is happening, but it's happening rather slowly. And while it's happening, other things are popping up that they need to incorporate, like data ops, like vector. These are all things that they need to be adding in, perhaps in priority order above reshoring what they already have. So it's very interesting to see where each vendor is and try to keep track of that and what they have, what they don't have, what they need to get, what they need to build. But what if price performance offerings for adjacent workloads in an enterprise, such as operational and analytical, have materialized? And I'm here to say that they have materialized, and there are some interesting uses of databases out there that are going to simplify your environment, and they're also going to bring you a ton of utility that you don't have today, and they're going to enable the transactional workload. So what is the transactional workload? We're going to get to that. I'm going to have several use cases for you to consider and find some representations of them inside of your own enterprise, and I know you can do it. There is a growing complexity for managing these many data workloads. And what has been the response? Silos. Fragmentation. Yes.
So sorry to interrupt, but you're just now on the decisions page.
Okay.
That's the logo page.
Okay, so is this showing?
Yes, growing complexity for managing. Yeah.
Oh, it's interesting. Okay.
Yeah. Now, yeah, I'm not sure what happened. Yeah, but we're good. Okay.
Well, yeah, okay. So I'm looking at the notes for the next slide, which is weird. All right. That's okay. So there's okay, like I was saying, growing complexity for managing these many data workloads. So what has been the response? Silos and fragmentation, a limited set of skills. Now, most people, most of you probably, as has been my case in the past, we live in one of the two worlds. We live in the operational world, transactional world, if you will, or we live in the analytical world, and that's what we know. And that's true for, I don't know, 90% of data professionals. But that is something that we'll need to address to go forward into this translytical future because you're going to have skills in both areas. As the lines begin to blur between OLTP and OLAP, right? And I assume that you already kind of know what that is. So I won't go into that in great detail. Just quickly, OLTP, online transactional processing, supports daily transactions like inserting, updating, and deleting data, and is optimized for fast data insertion and retrieval, but mostly getting the data in. And OLAP, online analytical processing, analyzes large amounts of data for BI reporting and data mining, and it's optimized for complex queries and data analysis. So there's still a separation out there for most workloads. It's just not as true as it used to be. And I'm going to give you several examples. And you might look at these examples and you might say, well, I could name that tune with an Oracle OLTP and a Snowflake OLAP. Yeah, you probably could, but not as well as you could with one database spanning the gamut there. So that's the point that we'll get into. Now, analytics. This whole webinar series is about analytics architecture. So what the heck is analytics really? It's a word that we throw around a lot. And I found myself in many conversations saying, okay, time out. I need to know what you mean by analytics. Analytics comes from the Greek word analytikos, which means the ability to break down or analyze. So the term is derived from analysis, which means a breaking up or a loosening. And that sort of fits how we use it in the enterprise today. We have projects that are classified as analytics because those projects are meant to dig into our data and come up with gems that we can actually use to improve the business. These are deep gems. These are not shallow. These are not, oh, William lives in Texas. Okay, great. These are deeper than that. They have depth. You have to do some probing. You have to maybe look around some different tables. You might have to have multiple transactions that come to bear on it in order for it to really be analytics and not just data. So there's those analytic projects, but there's also analytics that we add to projects. And these are just the metrics that we talk about: customer lifetime value, propensity to churn, ability to buy from us in multiple categories, things like this. Obviously, there's some math behind all of those things, and that's typical of analytics, that there's some math behind it. So anyway, analytics might be metrics in your organization. They also might be projects. They might be both. Okay, so that's where the term is going to come from. Analytics are needed even if they are not traditionally stored alongside operational data, like real-time customer event data, network sensor data, marketing campaign management data. So a lot of what I'm getting into here with Translytical has to do with real-time data. That is, the operation itself is not going to be optimized unless it is operating on up-to-the-minute real-time data plus historical data, analytical data, data that traditionally is stored in a warehouse downstream. Yes, we are going to continue to flow the data all the way downstream to the data lake, the data warehouse, etc. I'll show you that. But we need some of those insights in the operation as well. And I know we're sending selective analytics back to the operation to make it better, but it's more than that when you have a Translytical database. You have access in real time to up-to-the-minute data plus all your historical data. So you have a seamless platform. You can meet your operational data, your operational SLAs. So now I will put out this now because I'm thinking about it. Hybrid stores such as these can experience some latency. Some call this the data delta. This is when you're ingesting and synchronizing data from the transactional side for analytic replication. This latency is typically measured in seconds to minutes, depending upon the system and workload. We want to stamp out all of that latency. We want to have up-to-the-minute data, highly curated, actionable data in process in our operational environment. So we need to be bringing analytics to bear on that. The benefits of real-time analytics are speed to insight, better customer experience, because you have better data that you're using with that customer, operational excellence, and a deeper understanding. Most real-time architectures are about real-time ingest, but I would add to that the modern real-time architecture is not just about the ingest, it has to also be about the processing of analytics. These analytics will enable organizations to gain speed to insight, allowing them to make timely decisions and respond to the changing circumstances by the minute, optimally. It enhances customer experience by providing personalized and immediate interactions, improving satisfaction and loyalty. So let's look at some use cases that might be translytical. Here's a big list. Maybe you can find yourself in there somewhere, but the list goes on, and it's only limited by your imagination, really. I would venture to say that most applications are somewhat translytical. Now, think of it as a Venn diagram. There are applications that are clearly only one side or the other. However, there are applications that are both, and you can name that tune with a single database, or you can do it with two databases. What you have to decide is what is the downside of the overhead of having the multiple databases at play. I know you're used to it, that's one thing, but that really doesn't carry a lot of weight when you're talking about the optimal architecture. So let's go into some of these use cases. But before I do, some of the keywords that you're going to hear from me today and then in the future, as you hear other people talk about this topic, real-time analytics. Whenever you hear, I need real-time analytics, it might be a translytical database that would serve that need the best. Operational excellence, operational analytics, real-time data warehouse. How about that? That's a slightly older term, but it applies here as well. Real-time analytics essentially means that data is provided for analysis almost immediately once it is collected. This is the way of the future. The way of the future, and I don't know when, but it's not to have a second store of data. I know we've put all these resources into the data lake and the lake house and so on, and I still favor that. I still architect that. That is absolutely 100% what we should be architecting today. But somewhere down the line, that's not going to be needed. We're going to vectorize all data as it is manifest. And within that vectorization, we'll have all of the various uses of that data or the implications of that data on the entire enterprise that can be accessed from anywhere and utilized in the optimization of the enterprise. I know I just threw out a bunch of word salad there, but hopefully you get what I'm trying to say, which is that one data store for all data is probably our future. Translytical use cases, as you see here, they span financial services, including portfolio management, wealth management, and a whole bunch more. Why don't we talk about some in particular? And this one comes to mind all the time. Next best offer or next best touch from an organization to their customer. Now, it could be a B2B customer, it could be a B2C customer. We need to incorporate not only the analytics through last night, which would be a batch data warehouse type of situation, but also today, all morning, the last hour, and the last second into that screen render, into what we're knowing about that customer. At the same time, all of that data needs to be going into the derivation of the analytics for that customer. We need to incorporate not just the user data, but all user data, because we need to correlate the user to other users instantly. What did another user with a similar profile just do that was profitable to the company that we might want to do with this customer? Maybe somebody just became a correlated user, correlated to someone else, just based upon what they just did in their shopping cart, in their web navigation, and so on. Only AI can operate at the scale that I'm speaking of. We're going to have to bring AI to bear in order to come up with the next best offer. Some potential benefits of the next best offer strategies include increased conversion rates, improved customer loyalty, enhanced customer experience. They go on and on. So this is a big one, and this applies to pretty much every industry. Financial markets, billions of API request data. They need millisecond average query response. Now, the data includes not only the data that their concept is generating with the APIs and so forth, but also real-time and historical stock prices and premium data that comes from a growing community of curated partners. There's no end to this. Wall Street Horizon, fraud factors, audit analytics, value engine, stock twits, and much more. It's all of this kind of data that is useful to organizations, but only when their data architecture is at a certain level of maturity can they absorb this data in the right way to put it to use in real time. So real-time data in these financial markets, it's used for trading and investment decisions, market analysis, risk management, and algorithmic trading. The applications enable financial professionals to make informed decisions, identify trends, and manage risk exposure. The benefits include improved decision-making, increased efficiency, and enhanced risk management. So mostly from the third-party data, you can learn about trends, which involves identifying and capitalizing on market trends. Mean reversion. This is a strategy that assumes that asset prices tend to revert to their historical means. Well, that assumes we got to know what the historical means are, and there's no end to the calculation that is profitable to that type of strategy. Today, of course, we have a practical limit to it, but as we get more into AI, those practical limits will go away, and these transactions will be ultimately optimized. Statistical arbitrage. This strategy identifies price inefficiencies between correlated financial instruments. So we got to know what all the other financial instruments are being valued at right now. Market making. This strategy involves providing liquidity to the market by posting the buy and the sell orders. Where should the market be made at? Algorithms dynamically adjust these orders based on real-time market conditions and based upon historical conditions. So the more this type of application is translytical, the better it will be. And finally, I'll say sentiment analysis. As sentiments change out there in the market on a real-time basis, bringing that to bear in all of these things. Healthcare. Genomic medicine. I'll put that up at the top. It's a topic of high interest to me. I believe that DNA will be a huge data set that data architects of the near future, maybe us, will be working with. Now, I'm not an expert at this. You need a lot of training to really understand it. But I've done enough healthcare implementations that I've been around the subject enough to say a few things about it. To say that whatever we do, apparently, it's there. It's there in the DNA. How we will react to anything and everything is there in the DNA. Now, obviously, the exact environment cannot be created, but it can be simulated, and with a high degree of precision, our reaction to that environment can be determined ahead of time with our DNA. Again, a mouthful there, but hopefully it made sense. There's some more on this slide about healthcare that has to do with both the operational side and the analytical side working together. Virtual visits, telehealth and AI triage, AI diagnostics, and robotics that are automating lab work. Now, back to DNA. If our DNA is understood, there's some good things and there's some risks, obviously. With the DNA at our disposal, we have personalized medicine, early disease detection, genomic research advancements, precision health initiatives, targeted therapies, genetic predisposition identification, and new treatment developments. But there are concerns surrounding genetic privacy, data security, and informed consent. This is a big area, and I'm going to come back to earth here and come back to the subject of the day, Translytical. But I do believe that's a big area that Translytical will be involved in. That's why I bring it up. Retailers, yes. I talked about next best offer that applies here totally. Better and personalized product recommendations for consumers based on session data, historical order data, and trending products. Amazon does a pretty good job with this. I'm sure we can all agree to that. Market leading, but there's actually more runway to go for Amazon in this area to make it even better if they brought more data to bear. Continuous and automatic retraining of the ML engine, near real-time data integration from the retail application to the analytic platform, working together, being one platform, really. Identifying compliance issues with customer data and integration with all systems like ERP, email, and instant messaging. So putting out the right messages at the right time through these different channels, only by having a full 360-degree view over business operations. And that is best done with a translytical database. In manufacturing, you have predictive maintenance, quality control, supply chain optimization, production planning and scheduling, anomaly detection, and so forth there. Call out a few of them. Predictive maintenance, that's analyzing historical sensor data and equipment performance to predict potential failures and schedule maintenance. So it's not just about, oh, something's gone out of bounds here. It's about, well, what are the bounds? And maybe it should be different for each part, each individual part in each individual airplane or what have you. And in order to know that, you have to be bringing historical data to bear on the analysis. And so both historical data and up-to-the-minute data are important in doing something like predictive maintenance, doing it well, I should say, doing it optimally. And the idea behind it is optimizing your funds, your spend on maintenance. And this has to do with so many different dimensions, like where are the parts, how long does it take to put the part on, does it have to be in a refrigerated area, et cetera, et cetera. So there's a lot of things to bring to bear on something like that, and that is totally an AI application if there ever was one. Quality control, supply chain optimization, analyzing historical demand and supply data to optimize inventory levels, production planning, and logistics. How about anomaly detection? How do you know if something's an anomaly? Well, the history will tell you this. Identifying unusual patterns. Well, what's unusual? It's patterns that are unusual or out of sorts based upon the history of that particular part, person, product, whatever it is that you're looking at. Optimizing yield, optimizing inventory. And finally, we have asset management. So for this, I'll give you an example. There's a cybersecurity company called Oramus. They originally launched their platform using a PostgreSQL database. Okay, over time, the time-based data set got too large for Postgres to handle. At this point, the team migrated the data set from 400 plus PostgreSQL databases into a huge Elasticsearch translytical cluster of 160 nodes. Very big. So when you have assets to manage, you have to do that predictive maintenance, similar to manufacturing. You have to do risk assessment, similar to financial, asset performance monitoring, anomaly detection. Yep, just in a different vertical here, but anomaly detection, compliance monitoring, monitoring asset data in real time to ensure compliance with regulatory environments. Now, they don't update on a real-time basis, but conditions are changing in the data of your company on a regular basis such that they constantly have to be monitored to stamp out any compliance issues immediately so they don't grow. You know how data starts to grow, it starts to proliferate, starts to get used. We need to stamp that out early. So compliance monitoring, if you're in a translytical database, as for all these other things, you're going to be so much further along in your ability to handle the things that I'm showing you here. And finally, I will go into security surveillance. Obviously, security has a lot to do with history, has a lot to do with real time. So anomaly detection, there it is again. Facial recognition, using historical facial recognition data to identify individuals in real time and trigger alerts. This is becoming more common. Object detection, analyzing historical data to detect specific objects such as suspicious packages or intruders in real time. Predictive analytics, so you get resources at the places they need to be based upon a prediction of a security issue. Intrusion detection, analyzing data to determine if it's an intrusion, how deep is that intrusion, how to handle that intrusion, and so on. Access control and incident response. So that's a handful of use cases that lend themselves well to Translytical. So now let's talk about our architectural response to the need. Now, before I get into that, I will say that I do a lot of action planning with enterprises, and I assess their current state and design a future state for them. And I've been recently, in the past few years, that is, been more keen to try to optimize a certain area of data architecture for a client, like in a department, in a vertical or something like that, something more contained, because client data architectures are just really messy right now. And you can easily start boiling the ocean and get nowhere. So pick a use case to go for. Translytical, pick one that you can do in a reasonable amount of time, but one that's also at the same time pretty important to the business. And that will get you the traction that you need to deploy the Translytical database further. And if you're wondering what these Translytical databases are, I'll give you a few of them here in a short bit. But data architecture needs for Translytical workloads, the workloads I just talked about, fast streaming ingest, millions of events per second. We have a billion TPS coming. It's not here yet, at least not that I'm aware. We have, undoubtedly, in our lifetimes, a billion TPS coming. We also need low latency to ensure timely insights and decision-making, reducing the time between data generation and action. We need high concurrency with thousands of concurrent users. We need unlimited storage. We need pipelines that facilitate data integration, transformation, processing, and the creation of data products today. Transactional consistency. Yes, we need all that. And these features will help because they enable real-time decision-making that makes it scalable, reliable, and with efficient workflows. So now the data architecture that is not a great fit for Translytical is our legacy data architecture. So we have all these operational systems. Maybe I'm being progressive at calling this latency. You might look at this and go, I would really like to have some stream processing. Or I would really like to have a data lakehouse. Well, okay. But still, I got to say, it's legacy. It's fairly common to have your low latency data stream through Kafka or something into a data lake. At the same time, having your batch ERP and systems like that streamed with ETL. I shouldn't even say stream, but data moved through ETL processes or ELT processes into your data lake. And then selectively, we take data from the data lake and we move it to the data warehouse. We're not greedy about not sending data. Okay, we send data to the data warehouse, but historically, we don't send all of the data when you have a data lake because it's all there in the data lake. It's just not in a format that lends itself to great reporting dashboards and so on, all the things that we like to do with data in the data warehouse historically. This will all change over time, but this is definitely where it is today. And what we have here is this is my Chinese wall between the operational and the analytical. Okay, That's historically true and valid and how I've done it for years and years and years. Now, but what if there was a database that could span it all? One database that does analytics with, as well as can power operations. So estimating the exact percentage of databases out there that are translytical, well, let me put it a different way. Estimating the exact percentage of databases out there that are used as translytical, I would imagine is pretty low, on the order of maybe 5 to 10% of databases. But I think we come back here in a year's time, it's going to be double that at least, and optimally it would be a lot more than that. Many databases you're using today, like your Oracle, like your SQL Server, you may not even know it, but those are or can be translytical databases. Now, historically, we've used Oracle in a certain way, and let's face it, Oracle and SQL Server and the lot like that are great for both operations and analytical. I would argue that the vendors have better products than the straight Oracle database for analytical needs, and most of you are probably using those better products. However, you're probably not even aware that Oracle itself and SQL Server itself and blah, 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 I'll get into it, but they have these capabilities. So let me get to that by first talking about eliminating the wall and having a one database solution. Now, these solutions will be event-driven architectures. They will have Kafka-like connectors or some similar, like we like NATs, something like that. It will be a real-time pub/sub messaging platform. There will be edge computing. That is optimal. I think it was 2 months ago that I talked completely about edge computing and the need for that. So please check that out if you're getting into that. Selective feeds to a data lake. And real-time, okay, I mentioned real-time pub/sub messaging. What about single product architectures for translytical? As a matter of fact, that's sort of the only translytical by definition, is to have a single product. Now, I'm going to blur my eyes a little bit and say that, okay, yeah, if you have a couple products from the same vendor, it's really sort of one if they're highly integrated. But we're talking here about single table storage for transactions and analytics with fast IUD, insert, update, delete, as well as query. It's a simplified data architecture and it reduces data movement. Well, how does it work? How does it work, and why hasn't it happened before? It's because it's a lot of work on the part of the vendor to go there, and they don't go there lightly. It's a re-architecture in some cases, or it's the architecture that they chose when they started building the product in some cases as well. But it's a lot of work on their part. And what you usually end up with is a row store, which is what traditionally we're used to, with all the columns of the row stored contiguously on storage, or a column store where only a single column or maybe a few columns that you select that are used similarly are stored together on storage. And then you have a series of these to make up the entire row. And then the database decides. The database decides. The data is stored both ways, and the database decides when you issue a query, do I go to the row store or do I go to the column store? And I've vastly oversimplified it here, but that is really roughly how these translytical databases, for the most part, work. So you just keep your imagination open as we go forward. As I've said things like, well, in the future, there won't be a data warehouse. As I've said things like, you can use one database for both. Things like this. We suffer more in imagination than reality. Seneca said that, so I go with it. Column stores. This is a huge topic of mine. I've been beating this drum forever, going back to the Sybase IQ days and the early Vertica days and so forth. It's a data model, a big table with column families. So the column family is made up of the columns that you decide to store together because they're used together. I'm not going to go into a deep design session on how to do this, but I do want you to know that it's similar for your relational databases that are column stores and the so-called column stores of the NoSQL world that you'll hear about, like Cassandra or HBase or Hypertable. These all have this sort of paradigm of how data is stored by column. So the schema is rather light. There's no single point of failure. It's operationally simple. And column stores are the closest NoSQL implementation to a relational database. That point is probably not the most important point, but the Cassandras of the world, they are similar in terms of capabilities to what a relational database can do. And that's my point there. These are optimized for column-wide operations like count, sum, and average. Think about it. It can do those extremely fast because it doesn't have to access all of the data. You see, in a row orientation, which I'm not showing you here, in a row orientation, all the data is stored contiguously. And you have to overlook most of the data, for analytical queries at least, that you select because they're not applicable to the query. But you have to IO that data. And by IOing that data, you pay a price. And column stores say, you don't have to pay that price, just access what you need. HBase is like this. Hypertable, ClickHouse, Amazon Redshift, Google BigQuery, Snowflake, Vertica, Apache Cassandra, Apache Druid. All of these are column stores. Now, some of them give you the option of overriding it as a column store and just saying, okay, yeah, all columns equal the column family, so it's a row store. Okay, that's fine. But my point is that those are able to be column stores. Now, we're talking about large amounts of data where this makes sense. Data that needs compression. This is good for stuff like event logging, content management systems, and when the data model supports semi-structured data. Now, before I get too deep into the column store, let me show you this visual and hopefully we can move on. It's an important point when it comes to Translytical. For understanding Translytical, you have to understand column stores. Most HTAP, this is my Translytical, right? Use two storage types internally, an in-memory row store and a disk-based column store, what I just said. So this is a little visual representation here of a column store. These are 1, 2, 3, 4, 5 different possibilities for how you can take a table with, I don't know how many columns I have here, but a certain finite number of columns, I guess 5, is it? And you can do it any of these 5 ways, and probably more. Possibility 1, put them all in the same column family. It's basically a row store at that point. Possibility 2, don't do any design. Let them all be their own columns in terms of storage, column families. Possibility 3, okay, we'll combine those 2. Possibility 4, we got 1, we combine 4. Okay, you get the point. The readers in this architecture don't need to wait on the writers, thankfully, because the writing can be a bit onerous in a column store, can add some percent overhead. Each version of the row is stored as a fixed size structure. That is the complete desire of a column store because it puts each value at a fixed position on storage. So it doesn't have to do calculations like it would have to do if it were stored variably. Hopefully that made sense. Oracle has a dual storage approach rather than a single store like single store, the vendor single store. They're universal storage. Snowflake has announced combining with Unistore. And we replace a lot of the first generational operational databases like your MySQL, Postgres, and RDS and stuff like that. And we also augment data warehouses or even Hadoop to power real-time analytics with column stores. So architectural wise, this is from an actual vendor, TiDB, who is a vendor in this Translytical game. And as you can see, I won't go into it in detail, but as you can see, there is a row store set of nodes, and there is a column store set of nodes. And the compute layer decides where the query goes. This architecture is modular, cloud native, and designed for scalability and high performance. And to be complete, there's also some node metadata in there as well. But together, all these components allow HTAP to seamlessly scale out, ensure strong consistency, and support both operational and analytical use in one platform. Now, you might say, well, I'm doing Translytical, but I'm using different vendors and I'm bringing them together. Now, the set that I'm showing you on the screen right now, MySQL or PostgreSQL plus Apache Cassandra. Okay, the sets that I'm showing you are well-worn for a quote-unquote translytical application, but it's not truly translytical. It's not truly optimized. These are not vendors from, not products from the same vendor. These are not super integrated products. You're doing it. And there's still that flip of data from operational to the Cassandra or the Pinot, whatever the case may be, to get your analytics. And HTAP eliminates that. So organizations are often reluctant to attempt analyzing real-time data. They fear that the analytical workload will hamper the performance of the operational work. That has to be the priority, the operational work. But this is no more with HTAP. So I mentioned some vendors. There are also multiple multiple products within the same vendor that count to me as HTAP and are fully optimized, like TiDB and TiFlash, AlloyDB and Vertex AI, Azure Synapse Analytics, and Azure Cosmos DB. How about that? Now, who are the vendors, though, that are fully translytical? I kind of alluded to it before, but they're single store. That they are the granddaddy of them all in this area. TiDB, Oracle, I mentioned that. SQL Server, I mentioned that. Amazon Aurora, which is MySQL and PostgreSQL compatible database service that offers HTAP capabilities with its serverless and multi-master features. Now, you might have these databases, but again, I'll say, it doesn't mean you're necessarily using HTAP. I'd say 90, I don't know how many percent of Oracle databases do not use HTAP. They are just there for some transactional processing. But to give you an idea of how timely this subject is, Neo4j on last Thursday, launched InfiniGraph. This is a new architecture that enables their graph database to run operational and analytical workloads together in one system without suffering performance declines or forcing users to build duplicate infrastructures. So they're getting on this train, if you will. We did a benchmark. You know, we're going to do a benchmark on things when we want to know about them. So we did it 3 ways. And I don't have time to go into great detail here, but the first 2 ways are stitched together, different products, more traditional in nature. And the third way was with an HTAP database with a Kafka stack. In the TPCDS-like workload, non-official, we did TPCDS, not official, TPCH, not official, and TPCC, not official. We did that on all 3. What we found, and I'll sort of net it out here, was that we didn't really lose anything. I was expecting to lose things by using an HTAP database, lose some performance in analytical, lose some throughput on the operational side, but it didn't happen. It didn't happen, and actually we got a tremendously faster performance on both sides, and a savings of how much did we save? 2.5 times cheaper than the others over 3 years running enterprise equivalent workloads. So that's a lot. That's a lot. So there's some savings there for you. If you're just looking for straight up savings by switching to HTAP, they are there as well. Now, I promised a few slides on multimodal. Okay, major data types are being consolidated into multimodal. Almost all databases now are, at least in some ways, multimodal. Multimodal or multimodal database is a single integrated database that can store, manage, and query data in multiple models, such as, and these are the popular ones, relational, document graph, key value, column store, and cache. It's the opposite to polyglot persistence. which if you've heard that term, it's the use of multiple databases in a single workload. What is a workload? We won't go into that. But there is no Band-Aids under the hood to make this work in a true multi-model database. And these are some of the many data types that you will find in a multi-model database. Why am I bringing this up again? Because this has a lot to do with a database being translytical, being a good translytical database. Operational data types can be different from analytical data types. So you got on here, for example, you got log files, list actions that have occurred. Web servers maintain log files listing every request made to the server. With log file analysis tools, it's possible to get a good idea of where visitors are coming from, how often they return, and how they navigate through your site. So that's just one of the many data types. And notice I do have vector in there. Vector is becoming increasingly important and common in databases. Very popular, multi-model databases are very popular. This is from DB Engines from last week. And as you can see, it classifies 1, 2, 3, 4, the top 6. The top 5, excuse me, top 5, I can't count. The top 5 databases as multi-model. And if you just skip over Snowflake, which it doesn't seem to think is a multi-model, I would argue that, but the top 7 of the top 8 are multi-model. 9 of the top 10 are multi-model. Now, of the total, it's only 16%. If you just looked at this screen grab here of the first page, you would think, oh, so many are multi-model. Only 16%. But that's because these popular databases like Oracle and SQL Server, they've got the funds to make their databases multi-model, whereas you might have some more specialized databases, and there's definitely room for them in your architecture as you get down the list. But it's likely that a significant portion of multi-model databases in terms of deployments utilize only a subset of available data models, like maybe one, maybe just relational data. I would say well over half of Oracle implementations are just relational data. And that's okay if that's all that particular application needs, but over time, all applications will need not only translytical, but also multi-model. So this is another multi-model. It's another glimmer of hope around simplification. Example uses of databases. This is polyglot persistence. This is putting things together from specialist databases. Oracle for relational, MongoDB for document. Yeah, down the list. Everything seems pretty reasonable, I suppose. Spatial, you'll probably bundle that anyway, but I list it. This is for any individual application. Now, I would argue, and if I had time to go into multi-model, I would develop this argument, but I'm just going to put it out there that I would want to understand all the data types that I need to master in my database, and I would want to put that data into a database that is great for my top data types. At least it must be great for that, and it must be at least adequate for all of the ones that I want to use. So what do all these trends mean to an enterprise? All the ones I've talked about here. It means simpler data management, which I cited at the beginning, and I still say is a very important objective of most enterprises. You talk to CDOs, CTOs, they want a simpler environment. Unfortunately, they can't have it right away because they keep pushing forward into vector and streaming and master data management and so on and so forth. We need all that. So their job and your job as a chief data architect, as a data professional and an analytics professional, is more complicated than ever. You think, oh, well, with AI, aren't all jobs becoming simpler? No, our job is more complex than ever. It's not often we get a chance to simplify, but we have some chances right now with a unified platform, reducing silos, and maintaining the flexibility. HTAP databases are Many of them are also multi-model. Single store, for example, supports multiple data models, including relational, document, and graph. TidyB supports relational and document data models. There are also HTAP databases that are primarily relational, but they do have some capabilities in multi-model. Oracle, I mentioned, SQL Server, kind of in the same boat. You get, with multi-model and translytical, with these trends, you get unified queries, deeper insights, reduced costs, faster development. I think the TCO is there, and I proved it in the benchmark. So now it's time to play it out in your organization. Find the need, and there's a growing complexity for the need. Separation of OLTP and OLAP is not as true anymore. Many use cases that I went through, database requirements, streaming, ingesting millions of events per second, low latency, high concurrency, unlimited storage. So what's the response? A great architecture. Typically, HTAP stores as both row and columnar, and the HTAP architecture determines where to retrieve the data. A multi-model database is a single integrated database that can store, manage, and query data. So I talked about that as well. And there are benefits to simplifying the architecture. Good luck to us all on our journey to try to simplify while the demands are higher than ever. Shannon, that's the formal part of the presentation. Are there any questions?
William, thank you so much. If you have questions for William, feel free to put them in the Q&A. I think we have time for like one question here or so. And just to answer the most commonly asked questions, just a reminder, I will send a follow-up email by end of day Monday for this webinar with links to the slides and links to the recording. And everyone's quiet, but I know everyone's been super engaged. William, thank you so much. And thanks to all of our attendees. Really appreciate everyone's time today.
Thank you.
Thank you. Have a great day, y'all.